Good afternoon, everyone, and welcome to my YouTube channel. So, if you are new to this YouTube channel, just kindly like, subscribe, and share for more. So, let us make A-level chemistry a walk in the park. So, for today, we are looking at combustion analysis. How do you answer questions that involve combustion analysis? So, how or what is combustion analysis about? So combustion analysis, so as you know, many materials are made of carbon, hydrogen, and oxygen, and among other compounds such as nitrogen and chlorine. Now they are so numerous in the world such that it is very difficult for us to determine or ascertain what type of material we are looking at. So now, this is very crucial for us to understand why we use combustion analysis. Since the number of compounds are numerous as the sand of the sea, it is therefore very important for us to have a systematic way of determining the formula of a given compound. So now, combustion analysis, just as the name entails, you expose something to heat. Why exposing it to heat? So like, for example, let's say compound of A combines, or rather burns in oxygen. Now the products we know from the burning of hydroxides, mostly it's just carbon dioxide plus water only. So now, if we know the products, it means to say, if this compound had a product of carbon dioxide, whatever amount of carbon that let's say if this compound has got 12 grams of the compound of the product formed, this means to say this 12 grams, since it came from the compound A, whatever the 12 gram of carbon was also there in A. So now let's say it also has 7.1 grams of hydrogen. This 7.1 grams of hydrogen, the whole of it came exactly from the compound A, because there is, let's say, hydrogen in that compound. Then oxygen, since there is the oxygen, this one, and there is also the oxygen in here, we can be able to find the amount of oxygen in that sense. This will make more sense if I show you with the example that we have here. So now the question says that 0.658 grams of compound containing only carbon, hydrogen, and oxygen is burnt in excess oxygen gas. So the products formed are such that we have 1.285 grams of carbon dioxide and 0.658 grams of water are produced. If the molar mass of the compound is determined to be 90 grams per mole, determine the molecular formula. So now, here we are just going to first be able to identify. So there is this compound. We are saying that it is made with carbon. Let's say the carbon has got the subscript of X. It also has hydrogen with a subscript, let's say Y, and also oxygen with a subscript of, let's say, Z. This compound is burnt in oxygen to release carbon dioxide and water only. So with this equation, we should be able to determine the amount of carbon that was originally present in the reaction. So how is this possible? So for example, let's say you are given a test to say you can only get 100%. So let's say a test is out of 10. They'll say 2 divide by 10. Then they'll multiply by 100%, which will give them a 20%. So you have gotten 20%. Likewise, if let's say they don't want to make the test out of 20, they will say, let's say for your CA, they want the CA to be out of 40. What they'll do is, where there is 100, they will multiply by the total mark that you can get, which is a 40. So I'll say 2 divided by 10 times 40. This will be able to give us a value such that it is equal to 8. So this is the same as having a CA of 8. So this number is a number that we multiply to show the maximum amount that someone can get. So this is the same concept that we are going to be using. So from here, what do we have? We have been told that there is 1.2 we have been told that there is 1.285 grams of carbon dioxide. So the 1.285 grams of carbon dioxide was formed. So this is what we are going to do. So to determine the amount of carbon present in this compound, so we can say amount of carbon. So we have the amount of carbon. How can we determine the amount of carbon? So we can just say that the molar mass of carbon as a single unit divided by the molar mass of where is this carbon in a compound. So it is in carbon dioxide. So this carbon dioxide, then we are going to multiply. What are we going to multiply? We are going to multiply by the total actual mass. So we are going to multiply by the total actual mass. So we are going to say, we know that the mass of carbon is 12.01 grams over, what is the molar mass of carbon dioxide? So if we determine the molar mass of carbon dioxide, we are going to find that it is equal to, when we add this, we are going to get a 44.01. So we have a 44.01. Then we are going to multiply. What is the actual mass? So now the actual mass shows you to say that's the amount, the total mass of a given compound, just as we were doing for percentages. So this means to say we are going to get the value of 1.285 grams. So this value, when we multiply, we are going to have a 0.351 grams. So as you have seen, so this amount of 0.351 grams, this is the amount of carbon. So whatever carbon that we have now, initially where it's coming from, it is from the source. So this 0.351 grams of carbon, although it's in the product, it means to say that's exactly what was in here. There was exactly this amount in carbon to begin with. So we have already found our mass of carbon. Then we move on to finding the mass of hydrogen. We cannot go direct to find the mass of oxygen because it is also reacting with another oxygen. So it's more like the mass is mixed for oxygen. So therefore, we are going to first find the mass of hydrogen. So to find the mass of hydrogen, what are we going to do? So we know to say the same concept which I have introduced, we are going to use it here as well. So now, according to Dalton's law of definite proportion, we should also consider the amount of substance that can be contained. So in water, so we are going to say the hydrogen, the molar mass of hydrogen over the molar mass of the compound where it is found, which is our water. Then we are going to multiply this value times the total mass over H₂O. That is the actual, just as we did last time. So now, in water, you will realize to say water is made up of 2 parts of hydrogen. So this 2 needs to be taken into account. So we are going to say this is 2 times, we know the mass of hydrogen is 1.01. Then we divide this value, divide by, we have the molar mass of water. We are going to find that it's equal to 16. We have 2 times 1.01. So we are going to find that our mass for water, the molar mass, is giving us 18.02. Then we are going to multiply this with the actual mass that is present. So if you look at the actual mass present in water, we have 0.658 grams. So we have 0.658 grams. So when we do our math here, we are going to find that our mass is equal to 0.7 0.738. So this is what we have as the mass of hydrogen. So this is the mass of hydrogen contained in the compound. So we have found the mass of hydrogen. So now how do we find now the mass of oxygen? So this is what we are going to do. So remember, what we have is the compound, according to what we have been told, it has got 0.658 grams. Now, what we are going to do is, since we know that the sum is equal to 0.58 grams, we are going to add the masses. So the mass of carbon plus the mass of hydrogen plus the mass of oxygen should be equal to 0.658 grams. So with this, we are going to substitute. Our mass of carbon gave us 0.351 grams. Then we also have the plus the hydrogen that has given us a 0.0738 grams. Then we have plus the mass of oxygen, which we don't know, should be equal to 0.658. So when we add 0.351 plus 0.0738 is 0.4248, then we add the mass of oxygen should be equal to 0.658, which is our total mass. Collecting the like term, we are going to have the mass of oxygen should be equal to 0.658 grams minus we have 0.4248. Then when we subtract these, we are getting a value such as 0.2332 grams, like that. So we have the masses. So from here, we have found the masses. Now they want the molecular formula, determine the molecular formula. So how do we do that? So first, let us determine the empirical formula. So let me just write what our substances are equal to. So this is our masses. So now what are we going to do? So we have the empirical formula. Let us find the empirical formula. So what are we going to do? So we are going to say first, we have our mass that we have. Which elements do we have? So let's begin with, we have a carbon, we have the hydrogen, then last but not the least, we have oxygen. So we are going to put them like that. So carbon has got a mass of 0.351 grams. Hydrogen has got the mass of 0.0738. Then oxygen has got the mass of 0.2332 grams. Then we are going to divide the molar mass. So our molar mass of carbon is found to be 12.01 from the periodic table. Oxygen is 1.01. Hydrogen is 1.01. Oxygen is 16. So all these are grams per mole, but let's not bother ourselves, grams per mole. So we have that. Then we divide. What do we have as our moles? So our moles are equal to 0.0292. Then we have also, when we divide a 0.0738 divided by 1.01, we are going to get a value such as 0.0731. Then when we divide our last one, a 0.2332 divided by 16, we are going to get a value such as a 0.01575. So then here, we are going now to divide. We have the ratio. To divide the ratio, we are going to pick the smallest. So our smallest value here, since this is 0.07, 0.02, it is 0.01, regardless of the numbers that are there. So if we divide this number, we are going to get a 1 here. We are dividing this 0.01457 divided by itself, we are going to get a 1. Then 0.0731, we are going to divide it against 0. It's more like we are dividing it against 0.01457. 0.0575, but we are just going to write what the outcome is when we divide. So when we divide that, we have a 0.0731 divided by that value, we are going to get a 5. So here we are going to put a 5. Then last but not the least, when we divide a 0.0292 divided by 0.014575, we are going to get a value such as a 2. So this means that the empirical formula is equal to, we are going to just pick, so as you have seen, we have the carbon. As you have seen, carbon is with a 2. Then we go to hydrogen. Hydrogen is with a 5. So you just pick them like that. Then oxygen is with a 1. So now we have found the empirical formula. So now we need to find the mass of this empirical formula. So we using this formula to say, using the molar mass of this empirical formula will be equal to, we have oxygen is 16, we add it with 5 times 1.01, then we also have a 2 times 112.01. so when we add these, we are going to get a value such as it is going to be equal to we are going to get a 45.05 grams per mole. So finally, we know that the molecular formula and the empirical formula is related by molecular formula is equal to the empirical formula times the n. So the molecular formula from the question we have been provided, it's 90 grams per mole, should be equal to 45. The empirical formula mass is equal to 45.05 grams per mole. Then we multiply this by a discrete number n. Then this we are going to divide over 45.05 over 45.05, so that my n value becomes equal to a 2. So if n is equal to 2, what are we going to do? So if n is equal to 2, remember the formula is that molar mass, molecular formula is equal to the empirical formula times n. So we can just substitute. The empirical formula was equal to C2H5O. Then we multiply this, we put this value that we have had times a 2. So our molecular formula will be equal to, so 2 times C, it will have C4, H times 5 times 2 will be H10, then O times 2, it will be O2. So this is the required answer. Thank you very much for watching my video. Hope you would like, subscribe, and share for more. See you on the next tutorial.